Hello everyone. So your class is online class. So mainly you will go over the lecture and you will read the lecture. And if you have any question, you will email me. You can just email me and I'll try to answer your questions. So this lecture is not a complete lecture. Basically, I will briefly go over the topics. Mainly you will read the lecture notes and all the lecture notes will be posted on the Blackboard. So for this week, you will be learning chapter 1 and 2 sections from chapter 2. So in chapter 1, this is about overview and descriptive statistics. So in this chapter, we'll discuss about population samples and different kind of sampling, the sample mean, and we will also discuss about the descriptive statistics, and which will cover the sample mean, sample median, and standard deviation, and we will also discuss about the inferential statistics. So you need to know some term. For example, population sample. Population is full data set desired to measure, and sample is the representative part of the population. And parameter is the measurement which is related to a calculation which is based on the population. That's when parameter comes from population. And statistics, this is calculation based on the sample. And this is actually the estimates of the parameter. So we'll make inference about the parameter based on the statistics. So that's mean we'll make inference about the population based on the sample. So descriptive statistics will summarize and describe important features of the data. And we use graphs, calculations of middle or center or spread and locations. And in inferential statistics, this is the techniques for generalizing from a sample to a population. For example, if we want to know about the population mean, so we do not calculate the mean for the whole population. We collect a representative sample from the population, and then we calculate the mean for the sample. And based on this, we make inference about the population. So collecting data, we collect data in a different way. So there are some methods which is called simple random sample and stratified sampling, convenience sampling. So the two main methods of collecting data are through experiments and observations. So experiments observe the response of some change, apply some treatment to the situation. And for observation, we are not going to apply any treatment. We'll just observe the results. Okay, so the data we collect there are different type of data. So first we divide into two types, and first one is qualitative and the other second one is quantitative. And quantitative data has also two different types, discrete and continuous. So what is discrete? So technical numbers with a finite set of possible values. So discrete and the discrete data is the counting number of something, for example, 0, 1, 2, 3. So for example, if we consider the data that number of students, so number of students is counting number, right? Number of students could be 0, 1, 2, 3, 4, 5, 6. So this is called discrete. And continuous, for example, the score in an exam. So the score can take any values, right? From 0 to 100. So for example, one student's score could be 10.2 or 50.5 or 50 or 50.7. So it can take any number, or if you consider as the weight of a person. So this is also continuous, right? So that weight can take any number. It can take whole number or fractional number. So this is called continuous. Organizing data into tables. So to represent the qualitative data, we use frequency table or relative frequency table. So how do we construct the frequency table? So for example, we have a data set here. So the data is classified as freshman, sophomore, junior, and senior. So we have four groups, and this is the corresponding frequency. So that's mean this is the number of freshman students, 17, and 8 is the number of sophomore students. So this is called the frequency. That's mean how many times this this is happening, or how many students we have for this group. So this is called the frequency. So we can calculate the relative frequency. So what is the relative frequency? Relative frequency is frequency divided by the total frequency. So frequency for this group is 17 and total frequency is 30. So 17 divided by 30 is 57. So this is called the relative frequency. And for the sophomore, this is 8. The frequency is 8 and total frequency is 30. So 8 divided by 30 is 0.27. So this is also called a percentage. So if we write as a percentage, then it is 56.7%, and this is 26.7%, and this is 13.3%, 3.3%. So total is 100%. So since the relative frequency is related to percentage, so the total relative frequency will be also 1. So this is the representation of the qualitative data. So similarly, we can use frequency table for the quantitative data. So for quantitative data, since quantitative data consists of number, so we need to divide the numbers into different groups, and each group must be unique and groups have equal weight. So for example, here we have total 4 groups. So this is the credit hours. The credit hours from 0 to 120. So we divided 0 to 120 into 4 groups. And first group is 0 to 29. The second one is 30 to 59. And this is 60 to 89. And this is 90 to 120. Okay, so this is the corresponding frequencies. So for the first group, 0 to 29 credit hours, we have total frequency is 17. And for this one, the frequency is 8. And similarly, we can calculate the relative frequency. So the total frequency is 30. So 17 divided by 30 is 0.57. So this is the relative frequency for this group. And the total for the relative frequency will be always 1. Okay. So now we're organizing quantitative data into graphs. So we can also use graphs to represent the quantitative data. So we usually use histograms, dot plots, stem, and leaf plot. So in the histograms, the horizontal axis shows the groups. So here we had 4 groups. So the horizontal axis represents the groups, and the vertical axis shows the frequency or the relative frequency. And for dot plots, draw a evenly spaced number line that covers the range of data. So we just draw a number line, and this is evenly spaced number line. And this number line, on this number line, we will, and it should cover the whole data set. And we'll place a dot above the number line for each data value. So usually we use the dot plot for the discrete data. So for continuous data, we do not use dot plot. And for stem and leaf, so So we have here, we have this data set, 1990, 91, 92, 93. We can represent this data set by using stem and leaf plot. So the first digit is called the stem, and the second digit of this one is called the leaf. So we can divide its value into stem and leaves. So what are the stems here? So we have in the first digit, we have just 7, 8, and 9. So we have 3 stem here, 7, 8, 9. So we have 7, 9, 8, and 7. And corresponding to 9, how many loops we have? We have 0, we have 0. So we have 1, 0. Second one is also 0. Then we have 1, we have 2, we have 3. Then we have also 3. Then we have 4. And then you have to write all the loops here. Okay. And for 8, we have 1, 1, 5, 5, 6, 7. And for 7, we have 0, 5, and 8. Okay, even though if you do not have the data set, based on this, based on estimate leaf plot, you can have the idea of the data. So what are the data and what is the distribution of the data? So if you are given this estimate leaf plot, then from this one, you can have the idea about the data set, right? So this is one kind of representation of the data set. So from here, you can get that our data are 90, 90, 90, 91, 92, 93, 93, 93, 94, right? So that's mean this is all kind of representation of the data set. So from this representation, you can have the idea about the data set, right? So similarly, there are other representation. We can also use histogram and we can use also dot plot. So for histogram, um, the x-axis represents the group. So in our previous data set, we had 4 groups, and the first group was 0 to 29, right? And then 30 to 59, right? Yeah. And we had the corresponding frequency. So here the horizontal axis represents the group, the data values, and the vertical line represents the corresponding frequency. So the first group is 0 to 29. And in histogram, the bar are adjacent bar. So that's why there is no gap between these two bars. Okay, so for 0 to 30, the frequency was 17, right? So this is 16, so this is 17. So that's why the height of this bar is 17. And for the second group, the height was 8. So that's why, so the frequency was 8. So that's why the height of this one is 8. This is 17, okay? And so on. So for the dot plot, so the horizontal line represents the distinct number. So we have number from 0 to 120. So we have 0, we have also, and so for this data set, so what are the data? We have 0, 0, 0, 0, 0, 0 carried over. So we have 0, 0, 0, 0, and we have also 3. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7, 0. So for the value 0, we have 7 dot. 1, 2, 3, 4, 5, 6, 7, right? And for 3, so we have also 3 here. So this is 3 on the horizontal line, on the number line. And how many 3 we have? 1, 2, 3. So above this value, we have 3 dots. 1, 2, 3, because we have total three times. And then 6. 1, 2, 3, 4. So 6 is here, and we have 4, 6. So that's why we have 4 dots. Then 9. So how many? So here this is 9. So we have just 2 9. So that's why we have 2 dot. Then next number is 15. So we have just 1 15. So that's why you have just 1 dot above 15. And for 2, we do not have. Sorry, for stem 2, we do not have any number. And for 3, we have 30. This is 3 and this is 0. So 30, then 33, 34, 39. So for 30, we have 1 dot. For 33, we have 1 dot. For 34, we have 1 dot. And for 39, we have just 1 dot. And for 42, we have 1 dot here. And for 45, we have also 1 dot here. And for 51, we have just 1 dot. And for 54, we have just 1 dot here. Okay. So that's how we construct the dot plot. Then you can use the also bar chart. So horizontal axis are the categories. So usually we use the bar chart for the qualitative data, and we use histogram for the quantitative data. So for example, grades and classification. So for that example, so we have like four groups: freshman, sophomore, junior, and senior, and we have the corresponding frequencies. So for each group, you will have just one bar, and the height of the bar will be the frequency for this corresponding group, and the vertical axis is represents the frequency. So for the first example, so we had four groups: freshman, sophomore, junior, and senior, and we had the corresponding frequency. So for the freshman, the frequency was 17. So that's why the height of this bar is 17. And for the qualitative data, we use bar graph, and each bar should be separate. For unlike histogram, so histogram the bar was adjacent, right? And for we used histogram for the continuous data, but or for quantitative data, and for the qualitative data we use bar diagram. Okay, then shape of the graph. So if you have quantitative data, so if you construct the histogram or if you construct the estimate leaf, so looking at the representation of the data, like graphical representation of the data, you can get the idea about the shape of the graph. So look at, we have two graphs here. So we have two histogram here. So if you look at the first histogram, you can see it has just one mode. That's mean it has just one peak. So this is called unimodal. And here we have, so if you look at the shape of this histogram, we have two peaks. So that's mean this is bimodal. And you can have also multimodal data. So here we have three peaks here, right? So if you look at this one, there are three peaks. So that's mean this is multimodal. So symmetry and skewness. So there are, so if you look at the distribution of the data, you can see that. So if you look at the first one, so here, if you draw a vertical line at the middle, then we can see that this is the mirror image of the right part. The left part of the graph is the mirror image of the right part. So if you have this type of distribution of the data, then this is called the symmetric distribution. And if you do not have this type of distribution, so that's mean the left side of the data is not the mirror image of the right side, or the right side of the data is the mirror image of the left side, then this is called skewed distribution. So if you look at this graph and this graph, so if you draw a vertical line in the middle, then you can see that they are not symmetric, right? So that's mean they are skewed. So there are two type of skewness: left skewness and right skewness. So the left skewness is called negative skewness or negative skew, and the right skewness is called right skewed or positive skew. So that's mean if the distribution of the data has left tail, then it is called negatively skewed or uh, left skew. And if the distribution has right tail, then it is called positively skewed or right skewed. So measures of location, and we use actually measures of center for the measures of location. So and for measures of center, usually we use mean, median, and mode. So and that will give us the center of the data or center of the distribution. So if we calculate the mean from the population, then this is called the population mean, and which is denoted by mu. So this is called mu, and mu is for population mean, and we use x bar for the sample mean. And for the sample size, we use a small n, and for the population use size, we use capital N. So what is the mean? Mean is actually the average, arithmetic average of the data. So that's mean if you add all the numbers and divide by the number of observations or number of data, then it is called the mean. So if you calculate the mean for the population, then it is population mean. And what is the median? Median is the mid value of the data. So that's mean this is also center, right? So median is the middle value of the data set when the data is sorted from smallest to largest or largest to smallest. So that's mean first you have to order your data. So you have to order from either smallest to largest or largest to smallest. Usually we do smallest to largest. So then we find the middle value. So how do we calculate the median? So if the number of values in the data set is odd number, so that's mean if you have 5 observations in your data set, then the median is the n plus 1 divided by 2 observation. So for example, if you have 5 observations, then it will be, the median will be actually 5 plus 1 divided by 2. So that's mean the third number, if you order the number, then the third number is the median. And if the number of observation is even, so that's mean if the sample size is 6 or the population size is 6, so this is an even number, then the middle value will be the average of the two values. In this case, you will not have a single value in the middle. You will have two values in the middle. So if you just look at the example, then you can see it. So in the first one, we have 6 numbers, right? So that's mean it is even number. So if you look at the middle, we have 2 numbers in the middle, right? So you have to take the average of these 2 numbers. To find the sample median, you have to take the average of this 2 number. So what is the median in this case? 8 plus 10. So it will be 18 divided by 2. So the median is 9. So here you can see median is 9. And the median, the sample median is denoted by x tilde. This is called tilde. T-I-L-D-E, tilde. And mean is denoted by x bar. So this is called x bar. This is bar. And x bar represents the sample mean. And x tilde represents sample median. Then we'll discuss trimmed mean. So what is the trimmed means? So if you are asked to find the 10% trimmed mean, that's mean you will be eliminating the largest 10% and smallest 10% of the data set. So for example, if you have 10 observations and you want to calculate the trimmed mean, then 10% trimmed mean, then how can we calculate the 10% trimmed means? So if you have 10 observations, then you will remove all observations from the left and 1 from the right. Then it will calculate the average of the middle values, right? Average of the rest of the numbers. Okay, so then measurements of percentiles. Okay. So, and before discussing the percentile, we need to discuss about the quartiles. So that's mean if you want to divide your data set into 4 groups, so the median divides the data into 2 groups. So how do we calculate quartile? So to calculate the median, you already know how do we calculate the median. If you have odd number of observations, then this is just n plus 1 divided by 2th number. So, and if you have even number of observations, then you have to take the average of the middle 2 numbers. So, and why do we need quartiles? And we also use another kind of representation of the data, which is called 5-number summary. And for the 5-number summary, you need quartile. You need 5 numbers actually for this representation: minimum value, maximum value, and first quartile, second quartile, and third quartile. Second quartile, basically the median of the data set. Okay, so to calculate the quartile, first you will find the median. So once you have the median, your 50% observations will be on the left side and 50% observations will be on the right side. Now you can find the, if you consider this one as one data set, and you can consider this 50% as another data set, then you can find the middle value of this data set, right? And you can find the middle value of this data set. So the middle value of this data set is called Q1 or first quartile, and this is Q2, and this is Q3 or third quartile. So that's how we calculate the quartile. Okay, so and you can also find the minimum value of the dataset and the maximum value of the dataset. So now we have five numbers: minimum value, Q1, Q2, Q3, and the maximum value. Okay, measurements of proportions. Usually we use for qualitative data, and proportion is actually this is the relative frequency for each category. So if you think about the qualitative data, then the relative frequency is the percentage, right? And which is also known as proportion. Measures of variability. Okay, so what is the measures of variability? So the measures of variability is actually we want to know how the data is spreaded, right? So based on the center, we know the location of the data, where the data is located, right? Yeah. Now we want to know how the data is spreaded. So that's when we want to know the variability or spread of the data. So there are different measurements to know the spread of the data or the variability of the data. So we use range, standard deviation, or we also use variance for the, or we also use interquartile range for the measurements of variability. So now the question is, why do we need to know about the measures of variability? So why it is important? Okay, so sometimes just only based on the location, we do not have the complete idea about the data. So for example, if you want to compare two data sets, if you just know the center, or if you just know the mean, yeah, you have some idea about the data set, but you do not have the complete idea about these two data set. For example, if there are two classes and we want to get the complete idea about the score of these two classes, or we want to compare the students' capabilities um, of these two classes. So how can we compare these two groups? Okay, so based on the average score, yes, we can say, okay, the average score for this class is better, and the average score for the other class is low. So this class seems better than the other class. But the mean doesn't tell you the complete story. Okay, for example, so if each class has 5 students, there are two classes. If the class 1 has 5 students and class 2 also has 5 students, and their exam grade is, or exam score is, for example, for the first class, 0, 100. So we have 5 students, and for example, this is 90, 100, and 80. So what is the average score of this class? So the average score for this class will be then, um, so if you add them together and divide by 5, then it will be 200 plus 90. So 290 plus 80. So it will be 370. So if you divide by 5, then it will be, I guess, 74. So the average score is 74 of this class. Now, if you have, if for the second class, if the average score, so if the score for the students is, for example, 70, so this is 74, so 74 and 80 and 74. And maybe 72. So the average score for this class is also 74. Or we can consider some other example. So now if you look at these two group of students, then you can see that here one student failed in this class, right? So but in this class, the average scores for both class are same. So if you just have this information, if you have just the average score for class 1 and the average score for class 2, so do you get the complete idea about the score of class 1 and score of class 2? No, you won't get, because their average scores are same. But if you look at the individual scores, they're completely different. Here, 4 students have scores above 80 and 1 student has 0. But if you know the spread or variability of the scores, so for example, if you know the range means the difference of the maximum number and minimum number. So the difference is 0 and this is 80. So the range will be then, if you use R for the range, then it is 80. And for the range for this class is the maximum is 80 and minimum is 70. So it is 10. So now we'll get like more information about the data set, right? So here the range is 80. So that's mean that some students have really low score and some students has very high score, right? And here range is 10. So that's mean most of the students has somewhat similar score, right? So that's give us actually more information. That's why actually we know the measures of variability. So we use standard deviation. So if we calculate the standard deviation from the sample, then this is called sample standard deviation. So before calculating the standard deviation, we need to calculate the variance. So what is the variance? So for population variance, it is denoted by sigma square. So this is called population variance. And S square is sample variance. Okay. So the sample variance is S square is equals to 1 over n minus 1 summation of xi minus x bar squared. So this is the formula for calculating the sample variance. And for the population variance, we use actually capital N. So that's why it will be the population variance is summation of xi minus the population mean squared divided by n. So this is the population variance, and the standard deviation is the square root of the variance. So if you take the square root of this, then it will be sigma. So this is called sigma squared, and this symbol is called, this is actually called sigma. So sigma square is equal this one, and which is the population variance, and the standard deviation is the square root of this. So if you take the square root, then it will be sigma, and on the right side it will be a square root of this number. So this is called population standard deviation. Okay, so now we have the sample variance here. So what is the sample standard deviation? Actually, this is not correct. It should be n minus 1. Yeah. So we know the sample variance. So if you take the square root of sample variance, then it will be s, and the right side will be then summation of xi minus x bar square divided by n minus 1. Here x bar is the sample mean. So what does it mean? Actually, what we do here, first we calculate the sample mean, and we take the difference of center or difference of the mean from each number. So here we have 3, first number is 3. So we take the difference from the mean. So 3 minus mean is x bar, which is 3 plus 5, 8 plus 8, 16 plus 12. So this is 28. So divided by 4. So the sample mean is 7. So 3 minus 7 is -4. 5 minus 7 is -2. 8 minus 7 is 1. 12 minus 7 is 5. So then we'll take the square of each number. So the square of -4 is 16. The square of 2 is 4. The square of 1 is 1. The square of 5 is 25. Now if we add them together, then it will be 46. So 46 divided by n minus 1. So what is n here? N is a sample size, which is 4. So 4 minus 1 is 3. So 46 divided by 3 is the sample variance. And the sample standard deviation will be square root of 46 over 3, and which is 3.9. So this is the sample standard deviation. So you can use calculator to get the sample standard deviation and sample variance directly. So we also use interquartile range as the measures of variability or measures of spread. So what is interquartile range? IQR. So first you will calculate the third quartile and first quartile, and the difference between the first quartile and third quartile is the interquartile range. Okay, so there is another representation of the data, which is called the box plot. Usually we use the 5-number summary to construct the box plot. So in box plot, you need actually the 5 numbers. So what are the 5 numbers? The minimum value, the maximum value, the quartiles, first quartile, second quartile, and the third quartile. And if there is any outliers. So how do we calculate the outliers? So you have the interquartile range. So how do we calculate outliers? So we have the interquartile range. Okay, so we can have different type of outliers. So if the outliers are not extreme, then it is called moderate outliers. If they are extreme, then it is called extreme outliers. So what does it mean by extreme, or what does it mean by moderate outliers? So if the numbers are outside Q1 minus 1.5 times IQR, so that's mean if a number which is less than this number or greater than Q3 plus 1.5 times IQ interquartile range, greater than this number. So that's mean if any number is outside this range from this to this, then this is called moderate outliers. But if there are numbers which are outside this, Q1 minus 3 times IQR less than this number, or Q1 minus 3, Q3 plus 3 times IQR greater than this number, then they are called extreme outliers. So to construct the box plot, you need to know about the outliers. So you need to find the outliers and the 5-number summary. So if you have the 5-number summary and the outliers, then you can construct the box plot. Okay, so to construct the box plot, you will draw a line first, and this is the minimum number and this is the maximum number. Sorry, this is the not the minimum maximum. So you will draw a line first, then you will denote the 5 numbers. So we have 5-number summary, so we'll put the 5 numbers here. So this number is the minimum and this is maximum, and then this is first quartile, so you'll draw a bar here. This is second quartile and this is third quartile, and then you will add them. Okay, and you'll add this point to this point and you will add this point to this point. Okay, so this is called the box plot. Okay, now the question is, if you have outliers, then how do we denote this? So if you have outliers, then you have to use the asterisk sign. So if you have outliers on the left side, so that's mean then you will use asterisk sign. So this symbol means the data set has 1 outlier. So if you have 2 asterisk sign, then that's mean this data set has two outliers. If you can also outlier, you can have also outliers on the right side. So if you have asterisk sign here, that's mean we have outliers on the right side. Okay, so that's all about the first chapter. So if you have any question, you can ask me. So now I will give you, I will go over the second chapter briefly. So in the second chapter, we'll discuss about the probability. So for probability, we need to know about the sample space and events. So in the first section, we'll discuss about sample space, events, complement, union, and intersection. So union and intersection, that's when this is basically the set operations, then mutually exclusive. And in the second section, we'll discuss about the probability of an event and the probability of intersection, probability of the complement, and probability of the union. So we are not going to cover section 2.3 in this course. So only we'll cover section 2.1, 2.2, 2.4, and 2.5. But for this week, we'll just only cover these two sections. Okay, so sample space and events. So what is sample space? Sample space is set of all possible outcomes of an experiment. So that's mean if you do an experiment and if you collect all the outcomes of an experiment and if you write as a set, this is called the sample space. For example, if you draw a coin or if you toss a coin, then there are two possibilities, right? So the coin has two sides, head and tail. So if you toss a coin once, then what are the possible outcomes? You can have two possible outcomes, right? You can have either head or tail. So that's mean the possible outcomes are either H or T. H means head, T means tail. So now if you write them as a set, then this is called the sample space. So this is equal S. The sample space is denoted by S, the capital S. Or you can just write S. Okay, so this is the sample space. Now, for example, if you roll a die has six sides, and if each side corresponds a number. So if you roll dice, then you will have the six possibilities, right? You can have 1, 2, 3, 4, 5, or 6. So that's mean the possible outcomes are, there are six possible outcomes. So if you write them as a set, then this is called the sample space. So in this case, the sample space is S. So if you consider the gender of two kids, then both of them could be boy, and the first one could be boy, second one girl, first one girl, second one boy, and both of them could be girl, right? So there are four possibilities, right? So that's when the sample space S is equal this one. Okay, so what is the event? Any collection of the outcomes from the sample space is called an event. For example, if we just consider only the odd numbers from this sample space, then what are the odd numbers? The odd numbers are 1, 3, 5. So this is an event. So if you only consider the even numbers from this sample space, then what are the even numbers here? 2, 4, 6. So this is 2, 4, 6. So our event is, this is also another event. And the sample space itself is an event. So that's mean any subset or any collection of the, or if you consider just the first two numbers, then this is also an event because this is the subset of the sample space, right? Because these two numbers came from the sample space. So any subset of the sample space is an event. So there are different type of events. So usually we use capital letter to represent the event. So for example, A, B, or C, D, capital letter, we use capital letter to denote the event. So simple event. So what is simple event? If an event contains exactly one outcomes. Just if an event contains just one outcome, then it is called simple event. So for example, if we consider just one, then this is an event, right? This is the subset of the sample space. So this is a simple event. Or if we just consider two, this is also a simple event. So compound event, if an event consists of more than one outcomes, so this is a compound event, this is a compound event, this is also a compound event, this is also a compound event, because they have more than one outcomes. So complement of an event. So what is the complement of an event? So we know the sample space, right? So uh, for the dice, the sample space is 1, 2, 3, 4, 5, 6. So this is the sample space for the dice. Okay. So what is the complement? So our event A is roll an event number. So we have 2, 4, 6 for event A. So if we consider the complement of A, then the numbers which are not in A is the complement of A. So what is the complement of A? Oh, complement is denoted by prime. So for example, if our event is A, then complement is called A prime. And if the event is C, then the complement is C prime. So here in our example, we calculated C prime, that's been complement of C. So what is the event C? Event C is 3, 4, 5, 6. So complement means the outcomes which are not in that event, but in the sample space. So we have, in this event, we have 3, 4, 5, 6. So what are the numbers which are in the sample space, but not in that event? So in that event, we have 3, 4, 5, 6, but we do not have 1, 2. So the complement will be then 1, 2. So similarly for D, event D, what was the sample space? We had 4 outcomes in sample space, and we have 2 outcomes here. So then in the complement, we will have the other 2 outcomes in the complement. So we have these 2 outcomes in the event. So, and in the sample space, we had 4 outcomes. So other 2 will be the complement of this one. So this is the complement of D. So union of event A with an event B. So union is denoted by this one U, and intersection is denoted by this one, the reverse U. So this is called intersection, and this is called union. This is union, and this is intersection. So what does it mean by union of two events? That means set of outcomes contained in event A, in event B, or in both. So that's mean the outcomes which are either in A or in B. So union means or, either in A or in B. And intersection means and. So that's mean the outcomes in A also in B, if we calculate the A intersection B. Okay, so now we have event A 2, 4, 6, and we have event B 1, 3, 5, and A union B is the outcomes which are either in A. So in A we have 2, 4, 6, so they will be also in the union, and in B we have 1, 3, 5, they will be also in the union. So we have 1, 2, 3, 4, 5, 6. So A union C. So in A we have 1, 3, 5, and in C we have 3, 4, 5, 6. So sorry, in A we have 2, 4, 6. So you have to write 2, 4, 6. And in C we have 3, 4, 6. Since we already wrote 4 and 6, we do not need to write it again. So in an event, you do not need to write the same outcome twice. So that's why we just write 2, 3, 4, 5, 6. We didn't write 4 twice, and we didn't write 6 twice, right? Yeah. And D union E is the whole sample space. So intersection means common outcomes between two events. So A intersection B, so that's mean the common outcomes between A and B. So that's mean the outcomes which are in A also in B. We do not have any outcomes which are in A and also in B. So that's mean this is an empty set or null event. It doesn't have any outcome. It doesn't contains any outcome. So, and this is denoted by this, that means there is no event inside, or phi. So you will use either this sign or this sign for the null event. So that's mean if the event doesn't have any outcome, then it is denoted by this. You cannot use this notation. If you use this notation, that's mean this is not a null event, it is an event and it has one outcome, and the phi is the outcome. So either you have to use this notation or this notation. Okay, A intersection B is C. That's mean common outcomes between A and C. So what are the common outcomes? 4 is here, 4 is also here, 6 is here, 6 is also here. So there are two outcomes. So 4 and 6. So that's why A intersection is 4, 6. D intersection is, we have just one outcome, B, B. So this is the intersection of D and E. Mutually exclusive. So if any two events, the intersection of any two events is empty or doesn't have any outcome, then it is called, they are called mutually exclusive. So here A and B doesn't have any common outcome. That's mean they are disjoint or mutually exclusive. They do not have anything common. Okay, so you can also use the Venn diagram to represent different events. So usually we use the square rectangle for the sample space, and for the event we use circle. So if we have two events, so this is event and this is the sample space. So what is A union B? A union B means the outcomes in A or in B. So that's mean the region in A also in B. So that's why we shaded the region in A and B. So mutually exclusive, so that's mean two events doesn't have any common. So they do not have any common pairs. So that's mean they are mutually exclusive. They are separated. This is called mutually exclusive. And A intersection B is not empty. So this part is A intersection B, common in A and common in B. So that's mean the area which is shared by A and B. And complement of A, the outside of A. So that's mean the outcomes which are not in A but in the sample space. So which is the complement? So outside of A is the complement of A. So that's why we shaded this region. Okay, now we'll discuss the probability of an event. So if A is an event, then the probability of A is always between 1 and 0. So the probability of an event cannot be less than 0. That means cannot be negative, or cannot be greater than 1, because the maximum probability is 1. If something happens, the probability is 1. If something is certain that it is going to happen, then the probability it is going to be happened, then the probability is 1. So how do we obtain the probability? There are three methods: long-run relative frequency, equally likely events, and subjective events. Here we'll discuss mainly the long-run relative frequency and the equally likely events. So what is probability of A? Probability of A is, in the numerator, the ratio of number of ways event A can occur divided by the total number of possible outcomes. So probability relationship. So how do we calculate the probability of A complement, which is 1 minus probability of A, and probability of A union B is, and I'll show you why we have probability of A complement is 1 minus probability of A. This is probability of A plus probability of B minus probability of A intersection B. And probability of A union B union C is equals to probability of A plus B plus C minus A intersection B minus A intersection C minus B intersection C plus probability of A intersection B intersection C. Okay, first discuss about probability of A complement. So A complement, right? So for example, this is A, this is our sample space. And outside A, so this area is A complement. This is A complement and this is A. Okay, the total probability is, the maximum probability is 1. So the probability of the sample space is 1. because the sample space contains all the outcomes, right? So that's why the probability of S is always equal 1. So that's mean the total area of the rectangle is 1. Now, this total area divided into two parts, right? A and A complement. So that's mean probability of A plus probability of A complement is 1, right? So that's mean probability of A equals to A complement equals to 1 minus probability of A, right? And similarly, probability of A equals to 1 minus probability of A complement. Because if you add the probability of A and probability of A complement, which is equal 1. Okay, so now why do we have probability of A union B equals to probability of A plus B minus probability of A intersections B? Okay, so look at the diagram of A intersection B. So this is the A intersection B, right? Sorry, A union B. So this is our A union B. So we have the sample space A, and this is A, this is B. Okay, A union B. So that's mean this region and this region. So if you consider probability of A, so that's mean you are considering this area, right? You are considering this area. Okay. So we already considered this part. Yeah. Then if we add probability of B, what we are doing? We are adding this area, right? Now you can see when we considered probability of A, we already considered this part, this area. And when we added B, we added this area again. So that's mean we are added A intersection B twice, right? So that's why we have to subtract probability of A intersection B. So that's why you are doing minus probability of A intersection B. But for mutually exclusive event, probability of A union B, so that's mean the area of A and or area of B, right? Now you can see we didn't add anything twice, right? So in this case, probability of A union B is equals to just probability of A plus probability of B, because this part is probability of A intersect, there is no common. So that's mean we didn't add anything twice. So we do not need to subtract anything. So in case of mutually exclusive events, probability of A union B is just probability of A plus probability of B. And in case of mutually exclusive event, probability of A intersection B is 0. So you will not have this part because this is 0. And if ABC are mutually exclusive, then we'll not have this part. Then it will be probability of A plus probability of B plus probability of C if ABC are mutually exclusive. Now we will go over an example. So consider randomly selecting a student at a certain university and let V denote the event that the selected student has a Visa card and M be the analogous event for a MasterCard. Suppose that probability of B is 0.6 and probability of M is 0.4. Now we have to calculate, could it be the case that probability of V intersection M is 0.5? Okay, so the intersection actually is the part of event B and event M, right? So the area of this region cannot be greater than the total area of V or total area of M, right? Because this is the part of V and part of M. So it cannot be greater than V or greater than M. So what is the probability of M? 0.4. So that's mean the area of this region cannot be greater than 0.4. It could be equal. So when it is equal, if M is inside V, yeah, then the intersection is equal, right? Because this is the intersection now, because M is inside V. So this is the intersection. So intersection could be equal to one event, but it cannot be greater than any event. So that's why the probability of the intersection cannot be greater than 0.4. So this is not possible. So in part B, suppose that probability of the intersection is 0.3. So we are given the intersection is 0.3 and V was 6. So that's mean this is 0.3. So this part will be then 0.3, right? And the total M is 0.4. So this is 0.3. So the rest of the thing will be 0.1. Okay. Anyway, now we have to calculate probability of V union M. So what is the formula for V union M? So you can calculate it from the Venn diagram. That's mean this area plus this area plus this area, 0.3 plus 0.3 plus 0.1, then it will be 0.7. Or you can use this formula, probability of B plus probability of M minus probability of V intersection M. So 0.6 plus 0.4 minus 0.3, which is 0.7. Okay, so what is the probability that the selected student has neither type of curve? Neither type of curve means the complement that the students has at least one curve, right? So the student has at least one. What is the opposite of this? What is the complement of this? That the student has neither of the curve. So that's mean the complement of at least one. So V union M complement. And who is this 1 minus probability of V union M. So this is 1 minus 0.7. So this is 0.3. So per D is described in terms of V and M. The event selected student has a visa but not a MasterCard. The student has Visa card and the student doesn't have MasterCard. That's mean V intersection M complement. So we need to find the probability of V intersection M complement. So in this case, you can use this formula. Probability of V intersection M complement is equals to the event which doesn't have complement. So that's mean probability of V minus the probability of V intersection M. So if you use this formula, then probability of V is 0.6 and the intersection is 0.3. So it will be then 0.3. And part E is calculate the probability that the selected student has exactly one of the two type of curves. So how do you represent this event? So calculate the probability that the selected student has exactly one of the curve. So exactly one of the curve means the student has either the student has Visa card but not MasterCard, plus the student has MasterCard but not Visa card. So that's been probability of V intersection M complement plus probability of V complement intersection M. So we already know this part, which is 0.3. Now you need to calculate this part. So probability of V complement intersection M, so which is 0.1. You can calculate this one. Probability of V complement intersection M, which is this one doesn't have complement. So this one minus probability of V intersection M. So probability of M is 0.4 minus this is 0.3. So it will be 0.1. So that's why you have 0.1. So 0.3 plus 0.1 is 0.4. So that's mean the probability is 0.4. Okay. So this is also similar type of problem. So you can try this one by yourself. And if you have any question, you can just ask me. And this is also similar type, but here you have more events. You have 3 events. So you can also try this one, and the solution is given here. So you can just look at the solution. If you do not understand, please let me know. Okay, again, I am saying that the lecture is not complete lecture. So basically, you will read the lecture notes, which will be posted on the Blackboard. Okay. And if you have any question, you can ask me. Okay, thank you.